Here is something that will make interviewing for a GameMaker job a lot less scary. The studios that actually ship games in GameMaker, mostly indie and mid-sized teams, ask the same 15 or so questions, over and over. They want to know that you understand the object and event model, how rooms work, how you handle collisions, data structures, surfaces, and how you keep the game running fast. That is basically it. So in the next few minutes I am going to walk through all of them, grouped by topic, and give you the pattern that answers each one. The language, by the way, is GML, GameMaker language. If you can talk through these clearly and back them up with one small game you actually built, you are most of the way to hired. Start with the core, because almost every other question builds on it, the object and event model. First question they will ask, what is the difference between an object and an instance? An object is a blueprint. It defines behavior and which sprite to use. An instance is one actual copy of that object placed in a room. One enemy object, 40 enemy instances on screen. Get this distinction crisp, juniors mix them up constantly. Second, GameMaker is event-driven. You do not write one big main loop. Instead you put code into events. The create event runs once when the instance is born. The step event runs every single frame. Draw events handle rendering. Alarm events fire on a countdown, you set alarm 0 to 60, and 60 steps later the alarm 0 event runs. And collision events fire when two instances overlap. Third, and this one trips people up, you draw only in draw events. If you try to draw a sprite from the step event, it will not render correctly, because GameMaker clears and redraws the screen every frame in a specific order. Logic goes in step, drawing goes in draw. Keep those separate and you sound like you have actually shipped something. Next topic, rooms and layers. This is where your game world lives. A room is a level, or a screen, the menu, level 1, the game over screen. Each room contains layers. Instance layers hold your objects, and tile layers hold your tile-based backgrounds and terrain. Being able to say, instances go on instance layers, tiles go on tile layers, shows you know modern GameMaker, not the ancient version. To move between rooms you call room_goto, passing the room you want, room_goto of rm_level_2. There is also room_goto_next and room_restart. Simple, and they will expect you to know it. Then the follow-up they love, where does the game state live when you change rooms? By default, instances are destroyed when you leave a room and recreated when you come back. If you need something to survive, a music controller, or the player's score, you make the object persistent by setting persistent to true. A persistent object carries across rooms. You can also make a whole room persistent so it remembers its state when you return. Most teams keep global game state on one persistent controller object. Now sprites and animation, the visual layer, and a very common junior question. How does frame animation work in GameMaker? Every instance has an image_index, which is the current frame of its sprite, and an image_speed, which is how fast that index advances. Set image_speed to 1 and the animation plays at its normal rate, set it to 0 and it freezes on the current frame. That is the whole trick to, how do I stop this animation on a specific frame, set image_speed to 0 and set image_index yourself. They may ask about the sprite origin. That is the pivot point of the sprite, the position and rotation are measured from it. Set the origin to the center and the sprite rotates around its middle, set it to the feet and a character plants properly on the ground. To flip or scale a sprite, you use image_scale and image_scale. Setting image_scale to -1 flips the sprite horizontally, that is how you make a character face left or right without a second sprite. And when you need full control in a draw event, draw_sprite_ext lets you pass the sprite, the frame, position, x and y scale, rotation, a blend color, and alpha, all in one call. Movement and the step event, this is where a lot of beginner code goes wrong, so interviewers probe it. Remember, the step event runs every frame. That is where movement logic lives. GameMaker gives you built-in motion variables, speed for horizontal and vertical speed, and a combined speed and direction. If you set speed and direction, the instance moves automatically each step. GameMaker adds that motion to X and Y for you. That is convenient for things like bullets and simple projectiles. For a platformer or anything with precise control, most people skip the built-ins and move manually. They change X and Y directly, like X plus equals 4. More control, more predictable. Now the question that separates a hobbyist from someone ready for a team: how do you keep movement from being tied to the frame rate? If you just write X plus equals 4 every step, then on a faster machine the object moves faster. The fix is frame rate independence. You can check game_get_speed to read the room's target frames per second, but the cleaner approach is delta_time, the number of microseconds since the last frame. Multiply your movement by delta_time, scaled properly, and the object covers the same distance per second no matter the frame rate. Mentioning delta_time unprompted is a strong signal. Collisions. This is the topic where good GameMaker developers really show themselves, because the naive approach causes bugs. The key function is place_meeting of X, Y, and an object. It answers a yes or no question: if this instance were at that position, would it be touching that object? Notice you pass a position. That means you can check a move before you actually make it. This is the classic pattern: check the move before you commit it. So instead of moving into a wall and then trying to push back out, you write, if not place_meeting at X plus horizontal speed, Y, obj_wall, then move. If the space is clear, step into it. If it is blocked, you never moved into the wall in the first place. No jitter, no getting stuck. That single pattern answers half of all collision questions. There is also instance_place, which is like place_meeting but returns the actual ID of the instance you hit, so you can then do something to it, damage that specific enemy, for example. Finally, collision masks. The mask is the shape GameMaker uses to test overlaps, and it is separate from the sprite. You can give an instance a smaller or different mask than what is drawn. And you choose precise per pixel collision, which is accurate but slower, or a bounding box mask, which is a fast rectangle. Most games use bounding boxes and only reach for precise when they truly need it. Variables and scope. Short topic, but interviewers ask it because scope bugs are everywhere in beginner code. There are 3 levels. Instance variables belong to one instance, its HP, its state, and they persist for that instance's life. Local variables are declared with var, and they only exist for the duration of that one event or script call. They vanish afterward. And global variables live on the global scope, global.score, and any instance can read or write them. Then the 2 GameMaker specific things they will check. The with statement lets you run a block of code in the scope of other instances. Write with obj_enemy, then HP minus equals 10 inside the block, and every enemy instance takes 10 damage, because inside that block, HP refers to each enemy's own HP in turn. It is how you talk to many instances at once. And the other keyword. Inside a collision event, other refers to the instance you collided with, while self-referencing variables refer to you. Inside a with block, other refers back to the instance that started the with. So, damage other, in a collision event means damage the thing I just hit. Knowing with and other cold is a clear sign you have written real GML. Data structures, and the single most common gotcha in the entire language. Expect this one. For collections, older and still common GML gives you DS structures, DS_list for an ordered list, DS_map for key-value pairs, DS_grid for a two-dimensional grid, plus stacks and queues. And since GameMaker 2.3, you also have modern arrays and structs, which look and feel like arrays and objects in most other languages. Now the gotcha, and this is the question that catches people. The DS structures are not garbage collected. When you create one with ds_list_create or ds_map_create, GameMaker hands you a reference, and it will never clean it up for you. If you forget to destroy it, with ds_list_destroy or ds_map_destroy, that memory leaks for the rest of the session. Create a ds_list every step without destroying the old one and you will slowly eat all the memory until the game dies. The rule to say out loud: every ds_create needs a matching ds_destroy. Create it in the create event, destroy it in the destroy event. And the flip side, which shows real understanding, the modern structs and arrays are garbage collected. When nothing references them anymore, GameMaker frees them automatically, so they do not have this problem. If someone asks, which should I use, the honest answer is, for new code, structs and arrays are usually simpler and safer precisely because you do not have to manage their lifetime. Surfaces and shaders, the more advanced end, where senior questions live. A surface is an off-screen render target, basically a texture you can draw onto, then draw to the screen later. You set it as the target, draw into it, reset the target, and now you have a rendered image you can reuse. People use surfaces for lighting, for minimaps, for drawing an effect once and reusing it, for masking. Here is the big gotcha, and it is the whole reason surfaces confuse people. Surfaces are volatile. They live in GPU memory, and the GPU can free them at any time, when the window loses focus, when it resizes, on some hardware for no obvious reason. If you created a surface once in the create event and assumed it stays forever, one day it silently disappears and your game crashes or draws nothing. The rule: always check surface_exists before you use a surface, and rebuild it if it is gone. If not surface_exists of the surface, then recreate it with surface_create. Say that pattern in an interview and you have shown you have actually been burned by this, which is exactly what they want to hear. Shaders are the next layer up, small programs that run on the GPU to change how things are drawn, for effects like outlines, color grading, or dissolves. You wrap your drawing between shader_set and shader_reset. You will not be expected to write a complex shader on the spot, but knowing what they are for, and that they pair naturally with surfaces, rounds out the picture. Last technical topic: optimization. They ask this because a GameMaker game that runs badly is a real, shippable problem. Rule 1: do not do heavy work every step. The step event runs on every instance, every frame, so an expensive loop there, times hundreds of instances, times 60 frames a second, will melt performance. Throttle it. Use an alarm to run something every half second instead of every frame, or only recompute when things actually change. Rule 2: deactivate off-screen instances. If you have a huge level with 1,000 objects but only 20 are near the camera, you are paying for all 1,000 every frame. Instance_deactivate_region lets you switch off everything outside a region, and instance_activate_region brings them back as the player moves. Instantly cheaper. Rule 3: object pooling. Instead of constantly creating and destroying bullets, which has overhead, keep a pool of them and reuse the dead ones. And Rule 4: minimize draw calls. Batch your drawing, reuse the same texture page, avoid switching blend modes constantly. And the meta answer: do not guess. GameMaker has a built-in profiler and debug overlay. Turn it on, find the actual bottleneck, and fix that instead of optimizing things that do not matter. Then the real question underneath all of this: how do you actually get hired? You ship a small, polished GameMaker game and you show it. Not 15 half-finished prototypes. One complete little game, a menu, a couple of levels, sound, a win and lose state, proves you can finish, which is the rarest and most valuable signal there is. So there it is, the whole GameMaker interview in one frame. The object and event model: object is a blueprint, instance is a copy, and code lives in events with drawing only in draw. Rooms and layers, with room_goto and persistent objects for state. Sprites, driven by image_index and image_speed, flipped with image_scale. Movement in the step event, made framerate independent with delta_time. Collisions with place_meeting, checking the move before you commit it. Scope, instance, local, and global, plus with and other. Data structures, and the golden rule that every ds_create needs a ds_destroy while structs and arrays clean themselves up. Surfaces, which are volatile, so always check surface_exists. And optimization, throttle the step, deactivate off-screen, and profile before you guess. Master those, and there is almost nothing a GameMaker studio can surprise you with. But the thing that actually lands the offer is proof, one small, finished, polished game. I put a free written guide on breaking into the game industry at the link below. And if you want a portfolio that gets you hired, the Game Dev Portfolio Pack is in the description, $15, completely optional. Subscribe for more honest game dev career breakdowns, and I will see you in the next one.